So how are you doing?
Dwi'n da iawn.
Whoa. Sorry, what was that?
Cymraeg, Welsh. Dwi'n dysgu achos Cymraeg yw fy nghariad. I'm learning because my girlfriend's Welsh.
Oh,
Nice.
wow.
Do you know any physics words in Welsh?
Spoilers for the topic of this video. When a star reaches the end of its life and collapses, it forms a tush-D, or a black hole.
That's so cool.
They're really cool.
Hello and welcome to the second series of Physics Chat. Are you ready? Physics Chat is a show where we talk to a variety of physicists about their fascinating research and hear about what inspired them to become a modern day scientist. But I couldn't do this alone. I'm back here with my lovely co-hosts, Joe and Sergi. So tell me, Sergi, what are you most looking forward to on the new series of Physics Chat?
Well, for this season especially, I think I'm most looking forward to the guests because we will have not only professors and lecturers, but also people from other institutions.
That sounds good. Well, I'm most looking forward to asking my random questions. So without further ado, let's introduce our first guest of the series, the amazing Andrew Gow. Andrew is a postdoc at the Institute of Cosmology and Gravitation, researching primordial black holes. So my first random question of the new series of Physics Chat is, Andrew, what is your favorite TV show or film of all time?
Ooh, that's tricky, but I think I'll have to go with Doctor Who. I have a soft spot for it. It came out, the new series came back out when I was at just the right age for appreciating that sort of thing. I've always quite liked sci-fi, but that had a strong impact on me. And I've gone and watched all the old episodes from well, not all of them, most of them. Some of them are missing, unfortunately, because the BBC wiped the tapes.
Is that what inspired you to do physics then, sci-fi?
A little bit, definitely. I've always enjoyed sci-fi of various types, but a lot of the time the ones with the strangest scientific concepts, like time travel, like black holes, like moving through space at warp speed or whatever. And I think that led me to reading a lot of popular science books.
In one sentence, can you summarize your research for us?
Yeah, of course. So I'm studying, as you said earlier, primordial black holes, which are hypothetical at the moment, black holes that may have formed from the very early stages of the universe. And they could do lots of interesting things. Chiefly, they could explain the dark matter content of the universe.
I'm really glad we've got you on the show, Andrew, because in the first series of Physics Chat, we chatted to a few gravitational wave people, and they mentioned black holes because it's a lot about what they do, but we've never really talked about them properly. So could you just start off by describing just what a basic black hole is, what's going on?
Yeah, no worries. So typically the way we look at things is when a star reaches the end of its life, particularly a very heavy star, it will collapse due to the gravitational force, the gravitational pressure. And this is balanced by atomic forces, so electromagnetism and things like that. But if the star is particularly heavy, then the atomic forces cannot stop this collapse, and it forms what we call a singularity, a point of infinite density, and that is the center of a black hole. And that's all a black hole really is in gravitational terms. It's just one point of fixed mass but infinite density.
Okay, so how does space around a black hole get affected? What would happen to objects around there and things like that?
Yeah, sure. So if you're far enough away from a black hole, it looks just like any other body with some mass, basically. So if you're far enough away, it acts the same as the sun, the Earth, another massive object, some galaxy cluster. Once you're far enough away, everything just looks like a point mass. But as you get closer and closer, weird things start to happen. So there's this ring around the singularity called the Schwarzschild radius, or the event horizon. As you get closer and closer to the event horizon, time starts to do strange things. So you won't perceive anything different. You'll just carry on moving. But if someone were watching you from very far away, they'd see you slowing down more and more and more as you got closer to this event horizon. And they'd also see your light, you'd be dimmed and pushed to more red colors as you got closer and closer. And eventually, your image would stop exactly on the event horizon and then just fade away. they'd never see you cross this line because we cannot see anything cross the line. And that's because once you've crossed the line, to get back out again, you need to be traveling faster than the speed of light, which is impossible for anything in our universe.
Wow. Wow, amazing stuff there. And so, as I said, with gravitational waves, we've seen like the effects of these black holes, but can we see them directly in any way?
Yeah, we can. So, as you say, gravitational waves it's the closest direct thing we've seen for a while. The best we had was seeing the effects of objects orbiting black holes, because we couldn't see the black holes themselves. But with gravitational waves, we've seen something directly coming from the result of the thing. And also recently we had the Event Horizon Telescope, which is imaging directly a black hole. So it sees the matter that is the closest bit of what we can see to the event horizon. So we can't actually see the event horizon itself, but we can see matter just around the event horizon, and that's what the EHT does.
Wow. And it's something that I've heard probably from science fiction, but are black holes, if you went through it, would you appear somewhere else in the universe? Are they a portal in some way?
Yes, very, very sci-fi question here. I think the answer is this is not something I could say for certain, as I think is true of any scientist. I think the answer is probably no, but as I've said, we don't actually know what happens inside the event horizon, so no one can say for certain.
So as you have said, we usually think about black holes as being the end state of the life of a star, but that's not true for primordial black holes. So what makes a black hole primordial then?
Yeah, so a primordial black hole, exactly as you say, it doesn't form from a star. So it forms way, way back in the history of the universe, right near the start of the universe, when stars didn't exist. There are no stars. And there's a very fast period of expansion. I believe you talked about it with Joe Jackson last time. This expansion called inflation, the universe expands out incredibly rapidly. And when this happens, you can get areas of high density popping into existence. And if they're just sufficiently dense, then they can collapse directly into a black hole with no stellar processes, no nothing. Just the gravitational collapse at the end happens straight away. And this is really interesting because there's nothing to stop that collapse. Whereas with a star, I was saying there's all this atomic stuff going on that slows down the collapse or stops it. There's nothing in the early universe. Matter hasn't been formed yet. So these black holes can collapse whenever they like, with whatever mass they like. This is one of the key things. They could form with masses much, much smaller than the mass of the sun. In principle, we could have masses as small as very, very tiny, like atom size primordial black holes, or we can have something the size of a planet or the size of an asteroid, or any of these things are allowed. Or we can go all the way up to very, very big, many, many times the mass of the sun. All of these are allowed.
Okay, so then that's why they're called primordial, right? Because they're formed at the beginning of the universe, way before any stars are formed.
Yeah, exactly.
Cool. And you mentioned these range of masses that are possible with these primordial black holes, but what are the consequences in cosmology? Can we explain something? Can we solve problems with this?
Yeah, so the main thing that they could be useful for solving is dark matter. So this is something that we predict and know should be around from observations. So we've measured how heavy the universe is, and we've also measured how heavy all of the matter in the universe is, and the two don't line up. And we've also looked at how fast galaxies are rotating. And if you put it in with all of the matter you can see, you get a shape that's different to what you actually observe. But if you put in this extra matter called dark matter, everything fixes itself. The universe is shaped correctly, the universe evolves as it should, and these galaxies rotate the correct way. So a big question in recent years is, well, what is this dark matter? What is explaining the dark matter? And most of the time people imagine it's some sort of particle, some new type of matter that we don't know about. So, we have all of the particles in the standard model of particle physics. But if there's something outside that we can't detect very easily using our normal particle physics methods, or alternatively, it could be what are called MACHOs, massive compact halo objects, such as primordial black holes. So these you could have lots and lots of primordial black holes scattered through the universe, and because we don't know what the number of them is, we don't know how many there are, but they could then explain some or all of the dark matter component of the universe.
Yeah, that would be very cool. And so in regards of the observations, how can we know if the black holes we're seeing now through gravitational waves or the event horizon are primordial or astrophysical black holes?
Yeah, that's a really good question. So some of these, as you say, some of these black holes we've seen could be primordial. We don't know that the black holes we're seeing in LIGO or EHT or anywhere else are astrophysical rather than primordial. So how do we know for certain? Well, one key way is if we saw a black hole with a mass less than the mass of the sun, then that's it. You cannot explain that using normal astrophysics. It just cannot happen. So it has to be primordial. Unfortunately, that's quite difficult to find. LIGO can see this range, but it's a lot more computationally expensive than the range they normally look at. So it's a bit tricky. They are looking for it and they haven't found anything yet, which does place limits on how many primordial black holes there could be in that range. The other case is if we saw something that we could say for certain was a very high redshift, so something that happened very long ago, so far ago that it couldn't be formed from a star because the stars hadn't formed. That would also be another smoking gun signal. Unfortunately, measuring things very, very far away gets extremely difficult. Even if you could say that you've measured something that was formed in the first few seconds, you wouldn't be sure. The error bars would be so big that they could include the time after stars form as well. It's quite tricky to say for certain whether it's one or the other, but there are potentially ways of doing it, but they have flaws.
Wow, thank you so much for being on the show. It's been fascinating hearing about black holes and primordial black holes, and we wish you all the best in your research. It was interesting to hear how Andrew was inspired to do physics. Has any TV series or films inspired you, Sergi?
Yeah, I think everyone is inspired by some TVs or series at some point. And for me, it was actually a bit similar to Andrew. I like these sci-fi movies and series that make you think a little bit. Some examples would be Interstellar, Inception. Really like those.
Nice. What about you, Joe?
I guess what physics is in general is wanting to know how things work. And I remember watching like Wallace and Gromit as a kid and seeing these amazing inventions and all the cogs and wheels and these things going on, and just being very cool to know how just stuff worked in the world along with that. So I think that's kind of where that came from. What about you, Susanna? Have you got any examples?
Yes, I have. No judge, but Legally Blonde. I just love how resilient and determined she is. And yes, shout out to Reese Witherspoon. You're amazing in that. So anyway, let us know in the comment section what TV show or film inspires you. We would love to hear from you. Well, that's all we have time for on today's physics chat, and we hope you join us next time as we talk to some more interesting physicists. We have some awesome people lined up for you, so stay tuned. Otherwise, from everyone at Field of View, we hope you have a great day and goodbye. Bye.
Bye.
Dwi'n dysgu achos Cymraes yw fy nghariad.